Hello, I'm Gerard Fisher from WRAP, and I'm directing the project at WRAP on the development and implementation of buying guidance and specifications for buyers and specifiers of electrical and electronic products in the retail sector. As part of this work, we've developed summaries of different product categories in order to identify where failure modes are occurring and how they can be avoided through specifying components, design, and user guidance best practice. This webinar will focus on fridge freezers. After reviewing the project objectives, Mark Hilton, who is the technical expert who's helped to develop this product summary, will talk through the key highlights of the summary. Finally, I'll conclude the webinar and discuss next steps and where to find further information. Through WRAP's Electronic Products Pathfinder Group, industry recognised the need to identify design changes needed to increase the life of selected electrical products by bolstering durability. The end result will be guidance development for technical managers, buyers and suppliers to provide industry standard accessible content. A first step has been to research the most common failure modes within the product summaries, which provide a first step towards the development of more detailed guidance documents. In partnership with the Pathfinder members, we've selected washing machines, fridge freezers, vacuum cleaners, microwave ovens, kettles and televisions for assessment in these product guidance notes. The structure of the summaries is the same for each product and will include an introduction on how to use the document, the short-term failures that may result in a product being returned to you, the long-term failures that prevent it from reaching its long-term life, and then best practice in terms of component specification, design and user instructions. Finally, it will identify the opportunities for lifetime extension. So now for more detail on this product, I'm handing over to our technical expert.
Fridge freezers are generally pretty reliable things these days, but things can still go wrong both in the short term and in the longer term. So to start with the short term faults and some example causes of those, on this slide we've got a number of those, starting with broken shelves and trays, and this is a common problem that people have, and it's often down to overloading the shelves and trays in the fridge, but it can also be down to poor design or poor material choice. Cooling performance, again, sometimes the fridge freezer doesn't cool adequately, and that might be down to inadequate cooling flow at the rear of the unit. That in turn can be down to poor placement of the fridge freezer. So, for example, it's pushed up against a wall, very close to that wall, or this shelving above or whatever, to prevent proper flow. Thermostats sometimes fail, and that might be down to a poor component like the thermistor or control board as part of the thermostat. Bulbs sometimes fail. Fridge freezers often have the old style tungsten filament bulbs, which are, have an inherent weakness, if you like, compared to, for example, an LED bulb. And the thermal cycling that you get inside a fridge, variation in temperature, can cause that to occur. And then finally on this slide we mentioned gas leakage. That's something that generally would happen very early in the life of a fridge, and it might be down to a manufacturing fault or perhaps a damage to the circuit in transit. We move on to the next slide where we talk about longer term faults and causes. Compressors often go on fridge freezers after quite some time, and that might be brought forward by an overload of the compressor, again caused by poor placement of the fridge, or perhaps by the fridge freezer being out in the garage in the summer and there being a high ambient temperature, for example. Ice can build up and be difficult to remove. That can be caused by moisture ingress, in turn caused by a faulty door seal, for example, or a dirty door seal that doesn't sit very well on the front of the fridge. Sometimes you get faulty defrost systems on an auto defrost design. Another common problem that people complain about is blocked drain holes and water build-up. The fridge freezer has a drain hole in the fridge area to allow condensation and water from the defrost cycle to drain through, and gradually that drain hole can block, causing flooding inside the fridge. That could be down to poor design. It may be a narrow drain hole. It may be because the user isn't adequately cleaning the fridge and aware that they need to unblock that drain hole every now and again. Uneven cooling, maybe the circulation fan has failed inside the unit if it has one of those, or perhaps there's a general poor design responsible for that. Another problem can be around the way the door hangs. Eventually, if the hinges are of poor quality and there's a lot of load a lot of weight in the door of the fridge, then the door can hang down at one side a little bit, which obviously wouldn't look great and may affect the seal. And also, people want to move the kitchen around, move the device, the appliance, so that they need to open the door on the opposite side. Then perhaps the hinges aren't able to be switched over and the door handle's able to be switched over. That's another problem that can occur, resulting in a fridge being disposed of. We'll move on to the next slide, which talks about some of the various interrelated aspects of all of this and best practice. If we start at user instruction on the bottom right there, clearly it's important that users of the fridge know how to remove ice effectively, particularly if there isn't an auto defrost cycle. They know how to make sure there's good cooling flow around the back of the unit. They need to be aware of how to clean it and how to replace the bulb, for example, if that might need replacing. We're going to talk about design and component specification, the next two quadrants on this pie, on the next slide. So I won't go into any detail on those at the moment. But there's also an issue around standards and what standards apply when trying to specify better quality and more durable fridge freezers. There are no durability standards as such for fridge freezers, and although you can specify certain things around some of the components, there's no overall durability standard. Some of the safety standards are relevant, for example on electrical integrity, again of components. We'll move on to talk about some of these sort of design and component specification issues on the next slide now. So, design issues for durability and reliability. One thing that can be done quite easily is that the fridge freezer has built-in spacers at the back of the unit to make sure that the unit stands away from a wall, and that'll make sure there's a good airflow up the back of the unit. The shelving ideally should be glass that's well supported, reinforced glass I should say, that's well supported at its edges in terms of the fridge moulding and structure of the fridge. Any plastic trays that are in there, for example for the vegetable trays and fruit trays and so on, they should be made of a strong plastic such as polycarbonate. The door seal might be replaceable, for example, so that if it gets dirty and doesn't seal properly, then it's easy to remove and replace. And there are other things on the list that we've referred to an extent previously. So I'll move on to the next slide, which is talking about some of the opportunities for better reliability and durability in fridge freezers. On one of the previous slides we mentioned the compressor motor. Something that can happen there eventually is that the motor can burn out, and that's often due to overload and overheating. And one thing that can be done there, if we look at the opportunity column, is to fit a thermal overload switch, which will automatically reset to allow the fridge to operate again. So the fridge would temporarily switch off if the compressor motor overheated, and would switch back on again when it cooled down. That's a relatively easy and cheap thing to specify in relation to the motor, the compressor motor. And another thing that you might want to do is specify around the motor life, for example. and how many hours that's expected to operate, because obviously fridges run pretty much 24/7. All these things have cost implications, of course. An auto thermal reset switch, for example, costs approximately £1, and that would be added to the cost price of the unit. We've talked already about shelves and drawers and trays and things in fridge freezers. Again, that could be down to material choice. You may want to specify a different type of polymer for some of the plastic trays, or a different gauge of material. Maybe the way the moulding is done, and often you find there are stress concentrations in a plastic moulding on a fridge, which can eventually lead to cracking and the tray or shelf being unsupported, and hence the fridge freezer being no longer usable. So again, there are opportunities there, perhaps around broader design issues, and obviously this can lead to an increased, a slightly elevated cost, which would depend on a number of different factors.
Thank you. Full product summaries for all products will be available for download from WRAP's website from January 2014. Full guidance documents will be made available by March 2014, and there'll be further engagement on the format of these documents. For further details, please contact WRAP through Claire Ollerenshaw, the project manager, at claire.ollerenshaw@wrap.org.uk. Thank you for listening.